Hello everyone, and welcome to today's SQL Server Pro web seminar, Maximize SQL Server Virtualization Performance, sponsored by NEC. If you have any technical difficulties during today's session, please press the Help widget on your player console to receive assistance in solving common issues. And if at any time you are having audio difficulties or issues with advancing of the slides, simply hit your F5 key to refresh your webcast console. This session will include Q&A with our presenters, and we encourage you to enter questions you may have for our speakers at any time. Please also be aware, today's web seminar is being recorded and will be available on demand for 12 months starting tomorrow. You'll receive an email when ready to review. And now, I would like to introduce today's presenters. Michael Odie, Senior Technical Director for Windows IT Pro and SQL Server Pro, is President of Tekka, a software development and consulting company in Portland, Oregon. Michael Mitch is a Vice President of NEC Corporation of America's IT Platform Group. In this role, Mike is charged with forging and expanding NEC's North American alliances, sales, marketing, and support functions of NEC's enterprise servers, storage, software-defined networking, and software products through OEM, branded, and cloud channels. Mike has been in the information technology industry for over 30 years. And with that, Michael Odie, the floor is yours.
Hi there, I'm Michael Odie, Senior Technical Director for Windows IT Pro and SQL Server Pro. Today, we're going to talk about maximizing SQL Server virtualization performance. You know, without a doubt, performance is the database professional's #1 concern when it comes to virtualizing SQL Server. And while virtualizing SQL Server is nothing new, even today there are still some people that think that SQL Server is too resource intensive to virtualize. Well, we know that's definitely not the case, but there are some best practices that you need to follow in order to get the maximum performance from your virtualized SQL Server instances. In this webcast, we're going to cover some of those best performance practices for the hosts and for the guest, and see how a couple other technologies like the new Inmemory OLTP and dynamic memory fit into virtualizing SQL Server. So what this presentation is going to cover is we're going to look at some host configuration guidelines where we look at the host CPU, RAM, networking, and storage recommendations. Next, we're going to look at some of the guest VM configuration guidelines where we're going to look at the best way to configure VHDs as well as how to match those up with the SQL Server storage configuration. We're going to look at using SSDs with SQL Server VMs, and then we're going to look at using the in-memory OLTP option with SQL Server virtual machines. Finally, we're going to talk a little bit about software-defined networking and virtualization. We'll see how those two fit together, and you'll see the importance of software-defined networking with highly virtualized environments. First, let's talk about some host CPU guidelines. If it's possible, you want to make a 1-to-1 ratio of your virtual processors and the cores that you have in your system. If you do that, and you have one virtual processor to one logical core or one core that's in the system, you will make sure that all of those VMs that you're running are going to have physical processing capabilities and resources available when they need them. That's going to make sure that you maximize the performance of those SQL Server VMs out there, because you'll have cores and that are available to run the workloads that are running on those VMs and the virtual processors in them. There's nothing that stops you from overcommitting the physical CPU, so you can definitely do that if you want to, but that is not a practice that is going to get you maximum performance. If you want the maximum performance, try to match up your cores with your virtual processors. One other consideration is that if you overcommit the processors, you can limit the network bandwidth that's available to all of your virtual machines, because they do tend to use the physical processors to work with those virtual NICs. So a rule of thumb, more cores, that equals more performance per VM. Next, remember, as you're planning the cores and the virtual CPUs that you're using for your different virtual machines, the maximum number of virtual CPUs that are supported varies by guest OS. So you want to make sure that the guest OS has the support in it for the number of cores or number of virtual cores that you want to run. And finally, if you're running VMs in a host environment, make sure that that host supports second-level address translation. SLAT is, or second level address translation, is supported on almost all modern hosts. But if you're considering putting that workload on an older machine, then that support may not be there, and it is very important for virtual machine scalability. So that's definitely something to consider on the host side. Next, for the host OS configuration guidelines, first make sure you're using the latest hypervisor. For Windows Server, that's Windows Server 2012 R2 Hyper-V. For vSphere, it's vSphere 5.5. This is going to have the highest levels of scalability. Both of these systems support up to 320 cores or logical processors. They both support a maximum RAM per host of 4 terabytes, and the maximum RAM supported is very important for the number of processes and the workloads that you're going to run on your virtualization host. And the maximum size for the VMs is also highly scalable at 64 CPUs or virtual CPUs per VM, and up to 1 terabyte of RAM per VM, so the scalability is much higher. They also both have important support for other scalability enhancements like NUMA or virtual machine queuing and virtual receive side scaling. NUMA is a memory optimization technology that allows NUMA-aware applications like SQL Server to optimize the way that they use memory, and dynamic virtual machine queuing and virtual receive side scaling allow the host and the virtual machines to maximize their NIC throughput by balancing the workloads between the different NICs and virtual NICs that are available on the host and the guest. Next, let's talk about some host configuration guidelines. First, and this is especially true for Hyper-V, plan on reserving a 1 gigabyte of memory for that management OS. In other words, do not allocate all the memory that's in the host to the different virtual machines that are running. Instead, leave that 1 gigabyte reserved for the host so that the management OS can take care of the tasks that it needs to do for managing the different virtual machines out there. Next, look for hosts that support hot add RAM. Hot add RAM enables you to upgrade your host and add more RAM in it with no downtime at all. Many of today's virtual servers do support this, so that's something to look for. Also, when you're looking at host resources, look for dedicating one NIC for management purposes, and ideally dedicate another NIC for live migrations. And most of you are going to be using live migrations to move your virtual machines between hosts to account for scheduled downtime and maintenance. So that enables these tasks to be performed without impacting your production workloads, which would happen on other NICs that you dedicate to that. Especially in a highly virtualized environment, the network can be a bottleneck. So separating out those workloads from your production client connections to those virtual servers is an important thing. Also, look at separating your host OS from your guest OS VHDs. So if you're running on Hyper-V, make sure that where you're storing your Hyper-V host in Windows Server OS is a different place than where you're storing those guest OSs and VHDs. The idea is to split out the I/O to different spindles, ideally, different drives that are supporting them. And speaking of that, look at making sure that you exclude all of those VMs from antivirus scanning. Antivirus scanning will definitely impact the performance of a running VM, and you don't want those VMs to be scanned by an antivirus program. Some important guest configuration guidelines. First, make sure that all of the guests have adequate memory. This is especially important for SQL Server. SQL Server uses memory for its buffer pool, for the procedure cache, and that allows it to avoid going to disk. So it enables it to satisfy a lot of the processing and data requirements with what's in memory. And if it doesn't have that, then it has to go to disk. And if there isn't enough memory, then there's going to be paging and there's going to be disk I/O, and those things simply can't compete with RAM when it comes to performance. So if you're looking at optimizing those VMs, make sure that they have enough physical memory. You want to basically allocate as much physical memory as you can, for the most part, without overcommitting your host. Next, look at using fixed size VHDs for your virtual operating systems and your guests. Fixed size VHDs have much better performance than the other types of VHDs. I'll talk more about that in just a second. And then be sure to install integration services or VM tools into each of your VMs, depending on which platform you're using. These things put the optimized drivers for the different virtual devices in there. For instance, with Hyper-V, these would provide you with your synthetic network device or synthetic NICs, and which provide much better performance than the older legacy NICs, which you would have to have if you didn't install those integration services and put in those drivers. There are three types of different virtual hard disks you can choose when you are implementing your virtual machines, and basically your best choice is to use that fixed virtual hard disk. There's also dynamic virtual hard disks and differential virtual hard disks. Essentially, fixed virtual hard disks are going to give you the best performance, and what you see in this graph is a comparison between the physical disk and the fixed VHD, with the physical disk in blue and the fixed VHD disk shown in yellow. Fixed VHDs provide almost the same performance that you get out of a native physical disk. Differential disks are basically good for labs. They have one of the lowest performance levels. And dynamic disks, which are the default for virtual machines, provide pretty good performance, but they also can dynamically expand when the VHD needs more storage, and when that happens, there can be an impact to the performance of that VM. That's typically something you want to avoid in a production environment. So go with the fixed VHDs for the maximum performance for your SQL Server VMs. Next, when you're configuring those VMs, for SQL Server, you'll typically get an advantage if you take advantage of dynamic memory. This slide gives you a comparison of running 8 SQL Server VMs using dynamic memory compared to running 8 SQL Server VMs that do not use dynamic memory. The example on the left shows the VMs configured with 12 gigabytes of memory, and this is dynamic memory, versus the 8 VMs running with 7.5 gigabytes of static memory. And what happens is these are both running exactly the same workload. They are supporting 12,500 SQL batches a second. But the big difference is the VMs that have more memory, even though this is dynamic memory, are having a much lower amount of read IOPS. So the dynamic memory allows those SQL servers to avoid quite a lot of I/O. So it's 7,500 sustained IOPS versus 12,000 sustained IOPS in the static memory cases. So dynamic memory basically lets you put more memory on each of those SQL Server VMs, which is almost always a good thing, and more memory means less I/O. And dynamic memory is completely supported with SQL Server by Microsoft. A couple other important storage guidelines that you might want to remember is first, change the default placement of your data and log files. By default, SQL Server will put everything on the same drive as the SQL Server binaries themselves. This is never what you want for a production environment. Basically, you'll want to split out your data and log files to separate VHDs, and those separate VHDs ideally would be on different drives with different drive spindles. This way you're able to split out the I/O from those different drives so they don't compete with one another. That's going to give you the best performance for your virtualized SQL Server system. And when you're placing your log files, look at placing your log files on very fast writing drives, because log files record all those transactions. Look at using RAID 1 or RAID 0 for those kind of log files and the VHD that's going to be supporting those log files. The same thing holds true with Temp DB. Don't put your Temp DB on the same VHD as your data and log files. You're going to get a better performance if you're able to split it out into its own virtual hard drive. Again, use RAID 10 if you can, because that's going to give you the best possible write performance. And there's also an important practice that you might want to look into about how many Temp DB data files you configure per core that you have. The SQL Customer Advisory Team has a recommendation that's basically based on enterprise type workloads where there's one data file per core, again showing you how important the number of cores can be in the systems that you're running. Typically that's that's for a very heavy enterprise workload, and you can typically cut this down by quite a bit, but a typical recommendation would be for data files, 2 data files per every core, or perhaps 4 to every 1 core. So that's probably a more reasonable practice for most implementations. Next, let's have a look at SSDs. CPUs have become faster and faster, memory has become faster and more available. Systems today support much more memory than they did. That means disks have oftentimes gotten to be the bottleneck for many systems. SSDs can be a solution to that. They are simpler to implement than SANs, and for VMs you can move those VHDs to SSD files, and you'll get some advantages to doing so in many cases. SSDs tend to be much faster than rotational disks. A typical hard drive will deliver 150 to 200 megabytes a second of sequential throughput. An SSD can do over twice that with 550 megabytes a second of sequential throughput. So, and sometimes even more. So SSDs definitely can provide better performance than rotational drives. One thing about SSDs though is that SSDs, they do have a shorter life cycle than a traditional hard drive, and there is degradation with use, and the fuller the drive is, the faster it declines. So those are definitely considerations when using SSD drives. High I/O resource intensive kind of applications like SQL Server also intend to shorten the life cycle of an SSD drive. The drives will last for years. They won't last forever. A rule of thumb might be to plan for a replacement every 5 years or so. With SQL Server and especially Temp DB and things that get a lot of I/O usage, that could be even less. One thing to keep in mind though, don't ever defragment your SSDs. That's just a waste of time for SSDs, and many systems won't even run the defrag tools if you try to, because they're typically smart about SSDs. SSDs can provide better performance, but they're not a silver bullet. They're not going to fix badly written queries. They are not going to fix a lack of memory in the systems. You got to remember, your systems, especially your SQL Server VMs, they need to have memory to get the performance that you want. So you need to have enough memory in those VMs to perform well and to support your workloads, and just putting SSDs in is not going to be a solution for that. They're best suited for heavy random I/O, and remember, to keep the life cycle up and to keep their performance high, you want to keep the utilization of the SSDs at under 75%. Some possibilities about how you implement SSDs. Well, the best way is to put your data files on them. Your data files, if the SSDs are large enough to support them, that can provide a good performance boost there. Moving your log files would be the next thing. Indexes are almost ideally suited to put on SSDs. Temp DB is more of a questionable case. It's not always the best for SSDs because sometimes there's too much write with Temp DB, but it's definitely a consideration. There are different types though, and NAND, which is your standard SSD type of drive, where you're implementing it in a SATA kind of situation, does not always provide the best performance. Sometimes a PCI-based DRAM option would be preferable. They tend to be more expensive, but they also provide faster write performance. So anyway, a couple options for looking at Temp DB and SSDs. Okay, now let's talk a little bit about SQL Server 2014 and its new in-memory OLTP feature. The new in-memory OLTP engine was formerly codenamed Hekaton, and this is something that's found in the SQL Server 2014 Enterprise Edition. And with the new in-memory OLTP engine, basically this moves selected tables and stored procedures into memory, and it has a new optimistic lock-free engine that works to provide those with the highest performance possible. This a new in-memory OLTP engine can provide very significant performance gains for your OLTP kinds of applications, because it avoids that I/O of going to disk, because it's processing those tables and stored procedures entirely in RAM. Of course, this means that you really do need to have enough RAM in your physical or virtual machines to do it. So the amount of host RAM that you're running with is absolutely critical here. So the in-memory OLTP engine, to be clear, it works with a physical SQL Server system, or it will work totally just as well with a virtual SQL Server system, one that's running in a VM, but you have to make sure that you've allocated enough memory to that VM in order to move those select tables and stored procedures into memory to get that kind of OLTP performance boost that you'd expect by taking advantage of these new in-memory optimized designs. Again, to run this, it's key that you have enough RAM in your host to provide that RAM to those VMs that are all running. Next, let's talk a little bit about software-defined networking. Software-defined networking is essentially virtualization for your network, and it is essentially the same as server virtualization. Just like server virtualization abstracted your virtual machines from the server hardware, with software-defined networking, you are able to abstract your logical network from the physical network of the cabling and switches underneath it. And this is really important in dense virtualization environments. And it has a couple of real important features that can help you with your infrastructure. First, it can provide better flexibility and help you speed up your application deployment. Typically, when you have an application, that application will have certain subnet requirements. You may need to manually configure VLANs before you can deploy those applications, and that all takes time. With software-defined networking, you can build that logical network and deploy it along with your application, eliminating the need to manually build those VLANs underneath it, and instead the network virtualization will take care of manually configuring all of the actual physical network hardware underneath it. Software-defined networking is also very important for helping you to maintain your SLAs by providing predictable application performance. You can do this by controlling the bandwidth that you are providing to each of the virtual machines that are running on that software-defined networking. This ensures that the VMs that are running get the bandwidth they need, and that no VM takes up too much bandwidth, and the bandwidth for critical Tier 1 applications is available when you need it, so you can help to maintain the SLAs that your applications have. Well, that's it for my presentation. Thank you for watching. You know, we've talked about a lot of the design considerations for optimizing SQL Server in a virtual environment. Now, as you might guess, it's equally important to select the right server platform. Here, to share the latest advances in server technology, is Mike Mitch from NEC.
Thank you, Mike. Hello, everyone. I'm Mike Mitch, Vice President of NEC's Enterprise Technology Group here in North America. Welcome to today's presentation. To build upon what Mike Odie has presented, we're going to talk today about the unique attributes of the infrastructure technology required to realize the performance attributes of SQL Server running in a virtualized environment. Specifically, we're going to focus on the advances in server technology with the introduction of Intel's latest Xeon processor referred to as the E7 version 2, advances in system design to support the E7 version 2's unique characteristics, and how the network plays an important role when virtualizing SQL Server. Let's recap at a high level the key virtualization points that Mike outlined in his presentation, the significance to each, and the technology that is now available to realize these requirements. First, as we heard from Mike, the SQL advisory team recommends a 1 virtual machine per core ratio. Therefore, quickly, several virtualized SQL instances can demand a large core count. Utilizing the latest generation Intel processors with up to 15 cores can easily ensure that there's adequate physical cores for the virtualized SQL instances. Secondly, as workloads change, the need to add cores is an important ability. With a number of large cores that are now available, being able to optimize the core allocation dynamically now becomes a new consideration in advanced server designs. In a similar way, the ability to add memory to virtualized SQL workloads without downtime also becomes an important requirement. Adding to the fact that now we have a significant number of transistors in the system in terms of memory, processor, and I/O, it's even more important that the system have advanced technologies to not only allow for the detection and correction of errors, but to also take corrective action, such as reallocating memory and processor cores to ensure continued operation once thresholds are met. This is where having a history of knowledge in advanced machine check architecture really plays an important role of the solution. And lastly, now that we have virtualized, as we have heard from Mike Odie, the importance of the network becomes even more important for dense virtualization environments, and that it can speed the deployment as well as deliver the fine-grained network bandwidth required to virtualize SQL Server environments. To meet the growing and agile IT demands for SQL Server databases and the ability to tackle the most complex technical problems, Intel's focused on increasing the capabilities of the next generation processor that lies at the heart of the data center. The Intel Xeon processor E7 version 2 product family is that next generation of processor that replaces platforms based on Intel's previous E7 series. Continuing to build upon the success of the E7 version 2 product family has increased core count and cache size to deliver up to twice the performance across a range of workloads. These processors offer better than what Intel characterized as grunty and powerful performance to no matter what your constraint is, floor space, power, or budget, and on workloads that range from the most mission-critical virtualization and database to simple yet crucial multi-tenant web servicing and infrastructure applications. In addition to the raw performance gains, Intel's enhanced the Run Sure technology and advanced RAS features, so you can reduce the frequency and cost of planned and unplanned downtime while protecting data integrity. For example, the machine check architecture recovery execution path feature takes advantage of software layers to assist in the system recovery from data errors and to avoid fatal errors. The enhanced machine check architecture Generation 1 features provide augmented error log information for better diagnostics and predictive failure analysis for higher levels of uptime. Increasingly, broad industry support for RAS means that you receive the full benefits from your RAS adoption. Now I want to spend just a minute talking about, for over a decade, NEC has demonstrated consistent leadership in supporting the saleable SQL Server market. NEC first introduced a 16-socket system and was first to incorporate technologies such as Snoop filtering, cache bypass, as well as working hand-in-hand with Microsoft to implement the industry's first dynamic partitioning. This was used by Microsoft to develop the ability to expand a Windows partition in terms of core and memory expansion without requiring a reboot of the Windows operating system. NEC is pleased to have carried forward the benefits of SQL performance leadership into our 6th generation, the Express 5800 A2000. A great deal of this technology has been incorporated into Windows Server, which now delivers the support for continuous operation of the system. Here you can also see that for well over a decade, NEC has consistently delivered leadership SQL TPC transaction performance as documented by the Transaction Processing Performance Council. With a proven track record of engineering servers to deliver record-breaking performance, in addition to performance, we've engineered our enterprise servers, the next generation, to maximize agility for SQL users. We've done this with a technology called Core Optimization, or COPT. As mentioned earlier, as SQL workloads change, the need to add cores is an important ability. With a large number of cores that are now available, being able to optimize the core allocation becomes a new consideration in advanced server designs. With COPT, Users can add more resources the workload increases. Cores are added by an activation key used in the management console. It's that simple. Depending on the operating system environment, the additional cores can be added dynamically without the need for a server reboot. This pay-as-you-grow approach is a unique feature to NEC's next-generation enterprise server series. Also, as Mike discussed, another design consideration for optimizing SQL Server is the memory configuration, particularly with SQL Server 2014 Heckerton. SQL Server 2014 builds on the mission-critical capabilities delivered in the prior release by providing breakthrough performance, availability, and manageability for mission-critical applications. This means that customers have access to their data real-time as everything is in cache memory. There is no waiting for data to be pulled, retrieved from disk. Important to implementing in-memory solutions is the need to have a reliable and scalable server architecture. NEC's platform can have up to 4 terabytes of memory, double the amount of the previous platform. More memory means increased chances of error, so it's also critical that there are advanced reliability features built into the platform that avoid these points of failure in the server. NEC has taken steps by engineering advanced memory resiliency, such as dynamic memory page deallocation, so that in the event an error or a threshold is met, the system automatically takes corrective action to reallocate memory without a server reboot to avoid server downtime. We've talked about reliability features such as dynamic memory page deallocation and agility such as core optimization, and the importance in a SQL environment. NEC has taken RAS, reliability, availability, and service availability to another level by adding more Unix class features on the x86 platform. For example, depending on the operating environment, NEC offers a feature called CPU core spiring. In this case, if a CPU core threshold is exceeded, the server not only deallocates the affected core, but also automatically fails over to an available spare. In addition, the system is designed with redundancy core components such as spare service processor, system clock, and core I/O. That means that if any of the components fail or exhibit a threshold, the spare is automatically utilized and proactive action can be taken without outage. These types of features were designed specifically to reduce any single point of failure to ensure continuous operation and uptime. As Mike OT mentioned, think of SDN as virtualization for the network layer, delivering much of the same functionality and agility as server virtualization has done in the past. With a virtualized SQL system comes the need to ensure your networking topology can support SQL Server's I/O requirements, and they're not handicapped from the benefits of the virtualization technology due to the time that it takes to configure manual network resources. NEC has worked hand in hand with Microsoft's SQL product team as well as the server team to ensure that this technology is fully integrated. The integration of System Center 2012 with NEC's Programmable Flow Controller combined with the Programmable Flow 1000 switch delivers new levels of functionality to address these concerns. The introduction of this solution not only allows System Center to create and dictate network resources, delivering new levels of agility, it ensures that SQL Server running in a virtualized environment can maintain its service level without impact from other networking demands. Let's take a look at how this configuration works from the virtual level. Here you can see the servers configured with virtualization, Hyper-V, with separate instances of SQL Server, utilizing the NEC PF1000 switch. Next, we're going to look at the physical layer, which utilizes the OpenFlow protocol, delivering a truly open multi-vendor fabric, allowing to be controlled at the same level of fine-grained control as the virtual switches in Hyper-V. Next, we're looking at the NEC controller, the Programmable Flow Controller, or PFC. The PFC, which NEC refers to, delivers a flattened, open networking topology that simplifies network management, proactively addresses performance, and contributes to high availability of mission-critical processes such as SQL Server. The controller utilizes NEC's virtual tenant network technology, which allows administrators to build multi-tenant networks which virtual machine migration is unfettered, enabling rapid scale out of new applications, balanced workloads, and higher levels of availability. The programmable flow's centralized control of the network eliminates the need for distributed protocols such as spanning tree, reducing network complexity and unlocking the network capacity often made unavailable in existing networks. In addition, the programmable flow network also supports the integration with System Center 2012. System Center clients can now for the first time centrally allocate and manage network pooled resources in addition to storage and compute resources. When combined with the NEC A2000 server, this addresses the needs of the most demanding SQL Server users in the industry. Let's take a look at one firm which has chosen to move from a native SQL environment to a truly virtualized SQL environment, EdgeNet. This firm has been challenged to provide a multi-tenant environment due to the unique performance and network complexity issues associated with virtualizing a SQL Server environment. EdgeNet collects, optimizes, and distributes data used by various online retailers, search engines, and consumers. The company's systems process data for millions of products. EdgeNet must export critical data quickly and efficiently to online retailers and search engines that provide the data to shoppers. Fast access to consumer buying data is critical for satisfied customers and successful retailers. By adopting the NEC Express 5800 A2000 with the NEC Programmable Flow SDN suite has helped EdgeNet reduce costs by not only taking advantage of the benefits made possible by the Intel E7 version 2 processor, but also allowed EdgeNet to deploy multi-tenant SQL instances, driving new levels of consolidation. Improved availability also occurred not only because the A2000 advanced RAS features, but because of Programmable Flow's ability to immediately redirect and provision traffic associated with physical network issues. Additionally, the ability to dynamically provision not only the NEC A2000 server, but also the network resources at the same time through Microsoft System Center Virtual Machine Manager is configuring virtual machine instances. It allows EdgeNet to deliver faster agility and respond to customer requests in real time. This is one of the areas where NEC's technology in the server space and in the communications area delivers advanced differentiation that you can't find from some of the other vendors in the industry. Let's summarize the why NEC for virtualized SQL value proposition. The 6th generation Enterprise Server Series from NEC, incorporating Intel's latest E7 version 2 processor technology, not only delivers the highest levels of performance and workload consolidation built upon NEC's supercomputer technology, it also delivers the highest level of availability built upon NEC's mainframe-inspired high reliability technology. Combined with the decades of scalable SQL Server performance and a total virtualized system solution and network optimization, it sets NEC apart in the industry. As Mike Steinecke, VP of IT at EdgeNet, stated, it puts NEC a level ahead of the competition. So before closing, let's recap. Intel's next generation E7 version 2 enterprise processor family is now available in NEC's 6th generation Express 5800 series, the A2000, or what we call the CX system for core optimized. The system delivers the highest level of SQL workload performance and reliability in the industry, and when combined with NEC's programmable flow integration with Hyper-V and the extensible soft switch and System Center Virtual Machine Manager, delivers compelling TCO savings while improving agility to provide SQL customers new level of service to their customer base. This type of solution offering that demonstrates NEC leadership in computing and communications and provides the IT organizations with new choices designed to accelerate database and advanced analytics for on-premise and cloud computing environments. Lastly, please read Mike O'Day's recent First Look review by going to Windows IT Pro or searching on A2000 Windows IT Pro. We hope you found this presentation valuable by learning how new technologies are allowing Microsoft SQL Server customers to maximize SQL Server virtualization performance today. On behalf of NEC Corporation America and SQL Server Pro, we wish to thank you for attending this presentation. If you have any questions regarding this material, please feel free to contact me at Mike.
Fantastic. Well, thank you very much, Michael. And before we do begin the Q&A session, I would like to ask the audience to please take our survey by clicking on the red survey widget on your audience console. Also, joining us for the Q&A is Kim Stevens, Business Development Manager for NEC's product line, and she'll be available to answer questions as well. We're going to jump right into the Q&A. We have some questions, but we have time for others as well. So if you do have questions for anybody who spoke today, please feel free to put those in. And here's our first question. Do you have any public demonstrations scheduled? And I believe that's for the NEC team.
Yes, we've got several demonstrations coming up in the near term. This is Mike Mitch at Interop. We'll be in Las Vegas at the Mandalay Bay. We're a gold sponsor for that show this year. That's April 1st through the 4th. We'll be demonstrating SQL Server running on the A2000 in combination with Microsoft System Center utilizing the SDN suite. Also, we'll be at TechEd in May in Houston on May 12th through the 15th.
Great, fantastic. Here's our next question. As a DBA, should we be allowed to have read-only access to the VM host via the VMware tool?
Hey, Nick, I might answer that one. Generally, I think this depends upon the security standards that your organization has. Usually it is a good idea, though, for the DBA to have some sort of access to the VMs at an operational level so you can turn them on and off, in the event of an emergency, and also arrange to manipulate them and change their configurations if you need to. So I think generally it is a good idea.
Great. Thanks, Mike. Here's our next question. Should we defrag VHDs?
I guess I'll jump in on that one, too. Generally, it's not a good idea to defragment VHDs. Most of the time, the storage subsystems that you're running on them, or you're running them on, do not require defragmentation, although occasionally it probably is a good idea to defragment inside the guest OS, but not typically at the VHD level outside.
Fantastic. And here is our next question. What is the timing on E7v2? Do you know and or can you share?
I can take that one. This is Kim Stevens. The timing on the E7v2, this was announced officially by Intel on February 18th, which is in lockstep with when NEC announced this new A2000 server as well. And we will begin shipping these new servers at the end of March, so just within the next few weeks.
Great. Thanks a lot, Kim. Here's our next question. As a SQL DBA, should you have read access at the host level so you can troubleshoot performance issues?
This is Mike again. Mike O, that is. And this is very similar to the question that we had just a little bit ago, so it's obviously a common thread. But generally, again, the answer is yes. I think that you should, as a DBA, have access to the virtual machine console and to be able to at least be able to read things. But in many cases, you might need to want to perform configuration changes as well. So I definitely think it is a good idea. And the consoles, especially like with VMware, they can be secured so that DBAs only have access to their own SQL VMs and not to other systems. So generally speaking, it's a good idea.
Fantastic. Thank you. Here's our next question. How can I tell if my VM admins have overcommitted the CPUs for my SQL VM?
That is a good question. I don't know of a reporting tool that actually lets you see that right away. I mean, you could certainly construct one by using PowerShell scripts or other things that read the configuration of the VMs and report out. I think that might be one of the best ways to handle that kind of thing, is to create your own kind of report with PowerShell. And of course, you can go through the GUI admin tool for either Hyper-V or VMware and you can manually inspect the CPUs and the virtual CPUs that are running out there. That's another way that I think automated reports with PowerShell would be a more efficient way to do that.
Thank you, Michael. Here's our next question. The NEC presentation was very tailored to Hyper-V. Does NEC have any consideration or relationship with VMware?
Yeah, this is Mike. I'll take that. Yeah, absolutely. We have a large number of deployments that occur on VMware. Then we have customers running SQL Server on VMware. The reason we chose to focus on this was that there was some innovative approach with the integration on the software-defined networking strategy that's been put in place by Microsoft with the System Center and the soft switch. This is slightly different than what you're going to see in the VMware environment. I think that you can understand the differences between System Center and the way that Microsoft manages virtual machines as opposed to the way that VMware does from an application tier level. So that was the only reason. But we have a large number of deployments that take place in the VMware environment, and VMware is also fully supported on the enterprise NEC class server products.
Fantastic. Thanks a lot, Michael. Here's our next question. Do you think it is okay to place MDF and LDF files on a SAN in a virtual environment?
This is Mike. I guess I could answer that question. Generally, that's perfectly fine to do. You can place MDFs and LDFs on SANs, and SQL Server works great with a SAN on the back end. The one consideration you might want to keep in mind when you're doing this is that for performance considerations, you might want to make sure that those ones that are storing the MDFs and LDFs are on different spindles. So that's something you'd want to make sure you checked out with your storage administrator.
Fantastic. Thank you, Michael. What are the recommendations for working with NUMA, enabled and disabled?
What was that again? I didn't quite hear that.
Sure. What are the recommendations for working with NUMA, enabled or disabled?
Generally speaking, on multiprocessor systems, you'll get better performance with NUMA is enabled rather than being disabled. So NUMA is a performance advantage, and you typically would want to use it if you can.
Yeah, this is Mike. I agree with Mike. The memory controllers being integrated into the processors mean that the processors and the cores have local access to memory, that the memory hangs off of each of them. The NUMA coding allows SQL to optimize to ensure that the latency between that memory and that data is kept as close to the core as possible. As you get to larger processor machines, that becomes a very, very important element. So I completely agree with Mike on that.
Great. Thanks, gentlemen. Here's our next question. How does clustering or other high availability architectures play into virtualization to ensure the highest level of availability for the applications and their customers?
Mike, you want me to take the first one, or do you want to take that one?
I'll start off, and you can fill in where I might have left off. I think that overall, clustering is a great solution for adding high availability, especially to protect against unplanned downtime. In a virtualization environment, you can add it at two different levels. You can add clustering at the host level to protect the host from a single point of failure kind of scenario where all those VMs that are running on that host can fail over to another host in the event of a host hardware outage of some type. You can also implement clustering at the guest level, where a guest can fail over to a cluster node that's either on the same host or on another host, or sometimes even in a different host running in a different geographical location. So clustering, I think, definitely is integrated pretty tightly with virtualization, and it provides some good benefits both at the host and the guest level.
Yeah, I agree with Mike in that there's really, when you say clustering, it can be done at the hypervisor level, which is, I think that's a big consideration for a lot of admin. In the past, if you had a high availability SQL system that was not virtualized, you essentially, clustered the SQL instances, as Mike outlined. With the advent of a hypervisor and the ability to have the hypervisor clustered or to have it sitting in a standby mode, it offers another level of availability, but the characteristics are slightly different. in that the predictability for clustering the SQL Server instance across possibly VMs is going to be one level of availability. Clustering at the host level is going to give you a little bit different, and it's not necessarily what we're finding to be as predictable, because if you got a lot of VMs or if the system went down, the state to bring that host back up can vary somewhat. So it does become a very attractive approach for the infrastructure guys, because they can kind of do an N+1 type of approach where you don't have to have the dedicated clusters that you have to have for the specific SQL instances. So it's kind of interesting in that the hypervisor guys and the host guys are kind of going in one direction for clustering, and the traditional SQL guys are going, wait a minute, I need to have that exact concurrency. So that's one of the reasons why we see with SQL in the virtualization environment being mission critical, that people are saying, wait a minute, I need to make sure that that host is going to stay up, and that there's other features in the host that's available, like in the E7 product family with a machine check architecture, to keep the host live, so that in the event if the SQL admin don't get the opportunity to have that one-to-one clustering, that the system's going to continue to operate, and then that restoration at the host level is not as unpredictable.
Fantastic. Thank you. And here's our next question. What is the best approach to deploy a database replication server?
Not quite sure what that means, a database replication server. Databases certainly, and SQL Server does support replication, and you can configure it to replicate either to other SQL Server instances that are on site, or to SQL Server instances that are in a geographically similar site. Different types of replication are supported as well. So I'm not exactly sure if that really is hitting what the question is about. Then there's also another type of replication that's not at the database level, it's more at the VM level, and that is something you'd get with products like Hyper-V Replica, where it actually replicates the entire VM, not just certain databases, and you typically use that for a disaster recovery type of scenario.
Thanks a lot, Michael. Here's our next question. Since hypervisors abstract the processors into a pool with no control over thread placement on a specific core for execution, are there any noticeable impacts of the suboptimal cross-NUMA node lookups? And does it make sense to set processor affinity?
Mike, I guess I'll start off on. Go ahead.
Okay.
So from the processor affinity piece, from what we've seen, is that obviously that is going to allow a more fine-grained control over the latency between memory and the cores. Right, you're going to be able to do that. The NUMA piece is a part which has some the good news about that is it'll set it. The bad news about it is if things change, the NUMA awareness may not go ahead and move things around so that you're getting the maximum utilization out of the NUMA component. So for instance, if you've got affinity set for a SQL instance that's all on one socket, 6 or 7 cores running a terabyte of RAM, and there's another instance that's sitting on another processor that won't come in because of the affinity settings, and something changes, you're kind of limiting your ability to get that extra performance out of those extra cores and memory that's available because you've done the affinity setting. Conversely, with the ability to do the NUMA settings, it is going to dynamically look for those opportunities and go ahead and try to fill and to make sure that those resources that are available aren't being constrained. It's kind of continuously looking for that availability to keep the optimization in place. Mike, you want to add to that at all?
No, that makes good sense to me. I would point out that since we're talking about NUMA, sometimes it's a good idea to calculate the memory that's in the NUMA nodes so that your VMs can fit within that memory, and that applications like SQL Server are NUMA aware, and the hypervisors nowadays are also NUMA aware. So VMware's vSphere 5.5 and Hyper-V with Windows Server 2012 R2 both have NUMA awareness for the guest VM, so they can help to optimize the performance of NUMA aware SQL or applications like SQL Server.
Great. Thanks a lot, gentlemen. Next question. Can you tell me the pros and cons of having thick provisioning or thin provisioning for SQL VM servers?
This is Mike. I'll jump in quickly. Usually, thin provisioning is a good technology for helping you to more easily manage your storage. But thin provisioning does have a couple drawbacks, and there's sometimes a performance hit when you're actually allocating the storage because the storage isn't pre-allocated front, as is the case with thick provisioning. So a lot of times it's better to use the thicker provisioning things, especially with the Tier 1 application where you don't want to have any performance hits to the application as additional storage is being allocated for it.
Great. Thanks, Michael. Here's our next question. What is the single biggest challenge you have faced running SQL Server in a virtualized environment, and how can it be avoided?
Well, that's a tough one. There's a lot of different challenges that can come in. I think one of probably the biggest concern is performance. And performance, you have to make sure that the host platform you're running on has the processing power, the memory to support the virtualization workloads that you're running on it, and that you plan to support additional workloads. Usually it's a good idea to have planned for additional capacity if you're taking advantage of technologies like live migration where running VMs can be moved back and forth between hosts, and that suddenly adds to that host load. So you want to make sure that your host has the capacity to support these kinds of changes dynamically. So that's probably one of the biggest challenges. And one of the most common problems that I've seen for environments that set up a server consolidation environment is a lot of times they ignore the networking requirements, or they don't, maybe ignore is too strong a word, but they underestimate them, and so they don't often provide adequate bandwidth in the form of NICs and other types of QoS kind of configurations that they might need, and the network oftentimes can become a bottleneck. So those are kind of a couple of areas where you might want to take care and look at.
Yeah, I would echo what Mike is saying. What we've seen with we have a large base of customers that run native SQL Server, and EdgeNet was one of our early customers from 7-8 years ago through multiple generations of product, and they've always Mike's traditionally always run the systems in a native environment. It really wasn't until he could get enough of the performance and the platform to be able to ensure that he's got enough cores that he can allocate in a multi-tenant environment. Because again, one of the key things about running virtualization is the ability to run multiple, not just SQL instances, but multiple potential clients, right? So you've got to have that ability to ensure that in a cloud environment or in a hosting type of environment that you're delivering back the SLA so that one guest is not stealing from the other guest, especially at the network layer. So having systems that have a much larger number of cores running natively that allow you to do that, running with a system that's got 12 cores, that can pretty quickly run out of processing power. Something that has 60 cores, it's a different kind of game. And so the infrastructure and the platform, and then also, which we found very interesting to support Mike's comment, was that EdgeNet chose to go with an SDN solution with the extensible vSwitch from Microsoft with what's going on with Hyper-V. Being able to manage the physical layer and the virtual layer from the switch standpoint to ensure that the VMs all the way through the system out to to the delivery point have the predictable network and I/O bandwidth performance. So I would agree with Mike. It's really those two areas.
Fantastic. Thank you very much, gentlemen. And we have time for just one more question. How do I know if I presented too much virtual memory to the VM? Also, how do I know if you may be wasting that host memory?
Well, that's a relatively easy one. You can, inside the guest, run a performance monitor, take a look at the memory that's being consumed by that guest and the active memory. See if you're at your room or not. If that guest in performance monitor is not showing that you're using all that memory, well then you can easily scale it back by modifying the VM configuration settings. So performance monitor from inside the guest is how you can check that.
Fantastic. Well, I am afraid that we have run out of time for this seminar. I would like to thank NEC for making today's event possible, and I'd also like to thank Mike Odie and Mike Mitch for a great presentation today. Just a reminder, this presentation will be available on demand as well, starting tomorrow, so feel free to come back and review. Have a great day, everyone, and thank you so much for attending.